I took on a bold goal. I want to talk to you about the future of AGI. Maybe tell a little bit about how we got here. What is AGI and have we achieved it? And what that looks like in the technology we're building in the future. So I live in two now very much colliding worlds as a professor and as an entrepreneur. So as a professor at UC Berkeley, I'm one of the co-directors of the Sky Computing Lab, where we're reimagining how you interact with cloud services and using AI. I'm a member of the Berkeley AI Research Group, where we're studying advances in AI itself. I'm part of the EPIC Data Lab, thinking about how to make it easier for humans to interact with data at scale. And I was previously director of the RISE Computing Lab, which graduated, where we were thinking about how to build real-time, intelligent, secure, and explainable systems. My research spans AI and AI systems. I had the opportunity to launch the Vicuña models with my students a while back, and then the chatbot arena based on that work. And then since then, we've been thinking a lot about how to make AI more capable by giving it tools. Thinking a lot about how to manage the context of our agents so that we don't have to do recursive summarization, but we can manage memory more effectively. More recently, my group is very, very focused on post-training. How we augment models to do more advanced reasoning, to use tools more effectively. And my group is also actively involved in the development of the underlying systems. So projects like SGLang and VLLM came out of my lab. And these are efforts to build really widely usable open source tools to take LLM technology and deploy it at scale. I'm also an entrepreneur. I'm one of the co-founders of RunLLM. And at RunLLM, we are building the world's first AI support engineer. And today's talk will touch on some of the things we've learned in building AI products around RunLLM. I'm also an advisor to two other startups. I'm an advisor to Genmo, which is taking on the daunting task of building the next iteration of frontier video generation models. I'm an advisor to Leda, which is commercializing our work on MemGPT, building stateful agents. With my colleagues and with my co-founders, we run a blog that I actually recommend all of you check out, those who work on data or AI or both. This is a blog where we try not to talk just about the research, but how AI and products are evolving together, the lessons we learned, and some of the insights we've found. It's a lot of fun, pretty short, worth checking out. So as a professor and an entrepreneur, I often get asked a tough question. Have we achieved AGI? This question frustrates me because, one, I don't know what AGI means. It's ill-defined. And we keep changing the definition depending on the progress we make. Who thinks we've achieved AGI? Excellent. I have my hand up. By the end of this talk, I'm going to hopefully try to convince you that we have, but it's not what you think. Okay. AGI, what does it stand for? Artificial General Intelligence. There are three words here. I just have to make an argument for three words and our progress on each of them. Let's start with AI, artificial intelligence. We've been building it for decades. You go on the freeway, there are billboards for, buy AI for my company. What is AI? It's building computational systems that perform tasks typically associated with human intelligence. Things are reasoning, perception, planning. We've been working on this for a while. So our AI, the past 7 years, I've plotted different models. The y-axis is log scale, some data in a plot. Y-axis is number of parameters. So we go up to trillions of parameters a day. And over the past 7 years, our models have been getting bigger, gradually, and then much faster more recently. Right? So you see this huge growth in the size of our models. And as they got bigger, they got better. So here we've plotted various models on the computer vision benchmark ImageNet. And around 2015, we surpassed human intelligence. Take another benchmark like Atari, a very important benchmark for machine learning world. Can we play video games? And again, around 2015, 2016, we started to surpass the best Atari players in the world. Okay, so we play games well. Playing Go. In 2016, I'm guessing all you remember, when AI beat humans. Not only did AI beat humans, it learned new ways to play Go. So big breakthrough in our ability to reason, to learn. Who's driven in a Waymo? Been in a Waymo. Soon maybe on Market Street, right? Autonomous vehicles are actually in many cases safer than humans. Their perception is more accurate. So the planning techniques more advanced. Okay? Making a lot of progress. We're not there yet, but a lot of progress. Even in science, these technologies are really pushing the frontier of what we can do. Okay. So we've made a lot of progress in AI, but it hasn't been general. And this is the problem in our pursuit of AGI. Our state-of-the-art computer vision models, those that were better than humans, they could do computer vision in a very narrow domain. Atari, we can play Atari really well. We can build one model per game and beat a human. Sometimes we can build a model that plays a couple of games. Right? But we were still building very specialized models. Recognized speech. We'd build many models for different dialects, for different behaviors. We started to converge, but still we have a special model for speech recognition. Robotics, humanoid systems. A lot of excitement around here today. Our progress in the field has been great, but for each robot, we built a separate model. And sadly, even for each world the robot would live in, we'd build a separate model to get state-of-the-art results. Even if we take a really mature technology like recommendation systems that are pretty widely deployed, here again, each company would build a specialized solution to their customers, build specialized technologies that would achieve state-of-the-art, but we were building one model for each task. So back to our picture. By 2020, I'd like to argue we had made a lot of progress in AI. Agrees with that. AI was doing well. Okay, good. Not so much progress on generality, at least not in the broad sense. That doesn't say we weren't working on it. The research community has been looking at generality for a long time. And there are some big steps along the way you probably didn't hear about, right? So early 2010s, we were starting to learn common feature representations across images. By the early 2020s or late 2010s, we started to explore how we'd use language to get more generality out of our models. But then in 2022, what my students call post-ChatGPT, the era post-ChatGPT, the whole world started to find out about these more generalized models and what they can do. Right? There's a lot of work before ChatGPT. In fact, if you're in the research community, it seemed more incremental. But from the external world, it's like this big step forward in what models can do in the general sense. Right, so if we look at where we are today, a single model, any of these models, can accomplish a wide range of tasks. Can answer questions, write code, reason about images, write my homework assignment, my creative writing essay, prove theorems. And with in-context learning, with prompting, I can give it examples and teach it to do new things that the model creator never thought about. So I'd like to say, in at least the narrow sense, the words on this page, that we've achieved generality, or we've made enormous strides towards it, right? And that in this sense, we have achieved AGI. And it's this generality that we're all excited about. It's what's driving the impact in AI today. It's what's enabling vibe coding. So anyone can use AI to accomplish new tasks. And that is why the world's excited about AGI. And so I'd like to say today that we've brought the G into the AI, we've achieved AGI, and we should all celebrate. Now, many of you are saying, hold on, I was expecting something more dramatic, right? Perhaps you're expecting AI to be at the top of all companies, everywhere in the world, just talking about AI all the time, right? Maybe you expect the stock market to crash and the world to go to war, right? Some of you may have thought software innovation would change, or at least we'd have a new world of software innovation. All right, so two of these things completely unrelated, in my opinion, to AI. One is true, so AI has become a dominant part of most companies. Many companies are declaring AI as their core technology. The second one, I'd argue, is not true in a very bold sense. It is not the end of software innovation. I'd actually like to argue it's the beginning. Right? So AGI is only the beginning. And what it makes it so exciting, why it's still the beginning, is we have to go back to the basics that had driven all that specialization in the past and revisit them in the context of these new models. At the core of this idea is going back to the data. Data has always been and will always be the fuel of these technologies. How we use it, how we modify it, is critical to driving their success. We're also computer scientists. We have to go back to the problem. How we break up our tasks, how we feed them to these models makes an enormous difference. And then we have to go back to the models themselves and start to go in the opposite direction. We just start thinking about specialization. So what's next? We sought generality for decades. And now I want to argue we're going to go back in the direction of specialization. The pendulum has swung. And why did it do that? Well, generality gave us the ability to do many tasks well. With specialization, we can take that same model and do one task even better. So what does this mean for you? New problems, you should decompose them. Don't feed the big problem to the AI. You should really focus on using your data, and I'll talk about how in a few minutes, to adapt these general models, these priors, to new tasks. And you should solve specific tasks. Another way to look at this is all these models are just the new priors on which we'll build our next technologies. They're building blocks, not solutions. If you're building a company, your product needs to be more than a prompt. So I have an analogy I like to use for new grads coming from Berkeley. Who's had new grads from Berkeley? It's your companies. Come on, hire more new grads from Berkeley. They're great. Okay, if you're on the East Bay, you got to say yes here. New grads from Berkeley are full of potential. They're like instruction-tuned frontier models, and they're from Berkeley. So they can do reasoning and tool use. Okay. Who's given a new grad a hard problem? So we say solve climate change. Yeah. It's not going to work, right? What do we teach our new grads? Break problems down. You hire a new grad, don't give them the big problem, give them a piece, right? So say we focus on improving construction to address the challenges of climate change. How do we do that? Specialization. What's the first step? What do you give a new grad? Something to read. Go read about the problem. Go read about the domain. Right? This, in the parlance of AI, is this kind of in-context learning. It's what we prompt the model. It's the data we give it. We can use techniques like RAG to find the right data. It is all about the data. And I like to emphasize this is a place where we can actually innovate. Don't just feed the data. Read the data. You don't give a new grad just everything. You read the documentation. You create an onboarding document, right? You help them get up to speed quicker by processing that data in advance. This is a big opportunity for innovation in this space. Don't just run RAG. Don't just cleverly find the right documents. Read the documents. Create new ones that provide more information, more condensed. The other part of this process is on-the-job learning. Our new grads, we teach our Berkeley students a lot. But when they get to your company, they're going to change how they approach problems. How do they do that? One way they do is from demonstration. You show them how to do something better. This is what we call supervised fine-tuning, right? Another way they do that is you give them feedback. Hey, good job on that review. This is reinforcement learning. Okay? These are two mechanisms that are maturing very rapidly in the space of AI that you should be using to specialize models to your domain. But central to both these ideas is data. You have to use the data more effectively, right? So I need data to enable reinforcement learning. I need data to enable supervised fine-tuning. I wasn't going to focus on research today, but I want to highlight one of the things we've been doing at Berkeley, and this is the work on Gorilla and Raft, and this is building models that are specialized for these retrieval augmented generation, or RAG, domains. And the big idea here is to create synthetic data. We go through documentation. We read it with our model. We generate questions, answers, and explanations for each piece of documentation. And then we use that data to teach the model how to reason about our documentation, and then how to call functions to do new behaviors. This also lets us emphasize what's important to the model, so that we can have a model that's now specialized in things that are important to our company. You know, in the process of doing this, the model loses skills. It no longer tells jokes. It reads documentation. But that's okay. I don't want a model that tells jokes for this task. I want a model that reads documentation and solves problems. I have this mantra that I've been trying to get to the world, is that data is the new programming language of AGI. The way you think about these models, the way you specialize them, is really focusing on the data. Find the data, transform it to communicate the ideas that are important for your organization. All right, so we talked about specialization. We went out and specialized our model with data, with in-context learning, with fine-tuning, with reinforcement learning. Now we have a couple models specialized for different tasks, different parts of a bigger problem. We've got to put them together. How do we do that? We have to think about the tools, the services that exist in the ecosystem. AI is not useful on its own. It's when we put it with other things that we see big wins. I have some colleagues that make this case that the future is compound AI. And I'd like to argue so was the past. So even back in 2015, one of the most mature ad systems in the world, the ones running at Google, they made this case that machine learning is just one little block and part of a much bigger system. That bigger system had enormous blocks around data and infrastructure, around the services and tools, and had other models that were already supporting the data for the ad click system. All right, so I want to recap. Treat LLMs like new grads. Think of them as a source of opportunity, but to really use them, you need to follow the following steps. Step 1, look at your big problem, or even your small problem, and think, how can I decompose this into even smaller pieces? Given those pieces, really go back to your data. What are the opportunities that you have in your data to specialize the models with the knowledge, the context you give them, and the skills that they have? To use both in-context learning, what we prompt, and parametric learning, supervised fine-tuning, reinforcement learning, the techniques that are maturing today. And then compose those solutions to the smaller tasks using the tools and the software services that you have. Make them part of a bigger system, not just a standalone AI and a chatbot. And there's a fourth step that I haven't talked about yet. If you have a company, once you've done all this, you should call it an agent. Okay? And once you call it an agent, you should figure out what an agent is and actually instantiate that. And so I want to finish up by saying, what is an agent and why you should be doing that as well. So an agent is giving your model agency. You bring in your new grad and say, here's exactly what you do. Step 1, step 2, step 3. You won't have innovation. Like they'll do step 1, step 2, step 3, but possibly they should have done a step 4. Maybe they should have asked for more instructions. Let the model explore. So you should allow the model to take actions and interact with the world in a loop, using data, tools, and maybe even interacting with people. That interaction, that agency, allows the model to build up a richer context and answer questions more effectively, to be more effective. But as someone already pointed out, there's a problem in this whole strategy, and this is why agents have been tough. Because as you interact with the world, as a new grad interacts with the world, they build up a lot of stuff, and they will often get lost in the context they've created. That long conversation, what was I doing again? I forgot. Maybe I'm writing a story about a conversation with Jeff Bezos, right? So how we manage that context is a new data management problem. And there's, again, an opportunity for us to think about data as a first-class citizen in these systems. And projects like MemGPT were really focused on how we do that more effectively. All right, so now I want to turn to the company and talk about how RunLLM is really a case study in this story of specialization. So at RunLLM, we are trying to build the world's best AI software engineer. And I know it's the world's best AI software engineer because it's also the only AI software engineer, at least for now. So we're trying to build the world's best AI software engineer, or AI support engineer. World's only AI support engineer. What is an AI support engineer? Right? An AI support engineer is actually a pretty neat thing. So an AI support engineer is an agent that answers technical questions. So it does chat. So in some sense, we are building a chatbot. But if you had an AI support engineer that just chatted, it wouldn't be a very good support engineer, right? Okay, so it has to do more. It has to be part of the system. It has to improve documentation. It has to file bug support tickets. And it's also a human role. In some sense, by thinking of an AI not as some piece of technology, but filling the skills, the requirements of a human, we can scope what its responsibility should be. And that's really empowering when you're building these technologies to say, here's what it is that this person would need to do. So what makes a great support engineer? A great support engineer knows the product. This is, again, going back to the data. Read the documentation. Fix the documentation. Read the code. Understand what's going on behind the scene. The stuff you don't tell your customers. The support engineer needs to know this stuff. Can communicate effectively with the customer. It has to be friendly. It has to be trustworthy. It has to build the confidence of the customer. Interact with existing tools and services. It can't live in a vacuum. It has to work with the rest of the way your company operates. And it also has to work with the rest of engineering. It's part of a team that involves perhaps other AI and certainly other people. All right, so the remainder of this talk, I want to talk about how we build a great support engineer and what we have learned. But that's really hard. So I have Chenggang, our CTO and former student from Berkeley, come up and talk about what we're doing at RunLLM to solve these problems. Chenggang.
All right, thanks, Joey. Just to reemphasize, we can do software engineer, but right now we're really focusing on support stuff. So what it means is we, save engineering time, right? We accelerate user adoption, and we surface product insights. And another important thing to note is that we really focusing on technical support domain. So it's not about credit card refund. It's about things like how to debug NVIDIA's CUDA kernel or how to troubleshoot these LLM serving framework like VLM or SGLang. Those type of stuff are our focus. And for the remainder of this talk, we're going to focus on how we become a good support engineer at RunLLM. So the first step is to become an expert on each customer's product, right? This involves, building custom data processing pipeline to construct a knowledge base and then use a combination of retrieval augmented generation, or RAG, and fine-tuning to provide accurate answers to technical questions. And we then develop an agentic, buzzword, multi-step reasoning pipeline that allows customers to firmly control the AI's behavior while giving it access to, various tools via MCP. We'll then talk about how we integrate into customers' existing support workflows to generate business value. And finally, how we run some of the asynchronous LLM-driven analytics pipeline to perform things like conflict detection, sentiment scoring, and trend analysis. And as we go through each of these topics, we will also discuss how RunLLM treats data, how we do specialization, and how we do composition or decomposition. Before we dive into the details, I want to just step back a little and talk a bit about why generic LLMs like ChatGPT, right, these AGI stuff, are not enough, and why do we need specialization? Perhaps the most important part is a knowledge gap, right? There's no guarantee that those generic LLMs are aware of your product's knowledge. And even if they do aware of your product's knowledge, there's no guarantee that they're up to date. Because popular projects, like VLMs, these projects got updated on a weekly basis, while these base generic LLMs only get retrained on a yearly basis or so. And oftentimes, LLM may mix up knowledge, right, about your product versus your competitor's product and give out wrong answers. It's absolutely not something that we want. Another reason is ungroundedness or lack of trust, right? Because when ChatGPT generates some answers, it doesn't offer any citation to knowledge source, right? So there's no, guarantee or insurance about whether this is something that is hallucinating or if it's something that's actually coming from trusted support staff. And the last bit is unboundedness, right? Or lack of restrictions. As a company, it must have certain rules or constraints, right, about what kinds of questions are allowed to be answered versus not. For example, the support staff shouldn't be allowed to answer questions that are not relevant to the product, or sometimes these generic LLMs will be tricked into talking about the competitor's products, right, and being tricked into saying those products are actually better than our own product. This is definitely not something that we want. So that's why building product expertise with data that's unique to each customer is crucial. All right, so let's start talking about how we deal with data at RunLLM. You may think, that all it takes is to collect, all types of data we can find for a customer, like, official documentation, past support ticket, GitHub issues, and even code base, and just dump them into a vector database. Well, if this were the solution, technical support would have been a solved problem by the end of 2022. In reality, data quality matters a ton, right? So if we ingest these data in this raw, unprocessed, unclean format, it will not only generate confusion for the LLMs, and there's just no chance for these LLMs to generate any insightful answers because of these knowledge mix-ups. So our engineers at RunLLM spent a bunch of their time working on the world's most exciting problem. Can anyone guess what it is? It's called data engineering. Right? It's super exciting. So for each type of these data source, we implement a custom, data processing pipeline that decompose these data into chunks to be consumed by LLMs. And for example, for website documentation, we take advantage of those anchor tag as a boundary to keep the relevant semantic meaning and context in these chunks. And for code snippet, we respect those functions and method boundary and class boundaries. And for other types of data sources, we use a combination of hybrid chunking and also these LLM-generated summarization using GraphRag to further augment the text to improve the data quality. We also capture various metadata, such as the product version, the feature catalog, and whether this is something that's publicly facing or internal facing, and attach them as tags to these data chunks to further augment the quality. And once we have this clean knowledge base, right, we use RAG to get grounded response. And everyone have some knowledge about RAGs, right? So at the high level, it's really nothing complicated, right? So when a question comes in, we do a knowledge retrieval against VectorDB. We combine those docs with the questions, pipe that into the LLM, we get the answer. But the devils are actually in the details, right? So remember, data quality is really the king. And we want to make sure, to take whatever we can, right, to make sure the data that actually arriving at the final generation LLM is in its cleanest form with no ambiguity. So we do a lot of data engineering during this inference process as well. When a question comes in, the first step that we do is actually called tag filtering. So we extract common tags from the questions, for example, product version, and use those tags as a filter before we reach vector database. Remember, we can do that because in the knowledge ingestion phase, we already extract those tags from the knowledge source, right? So we're aware of these tags. And then we use a combination, not just vector search, but a combination of text search and vector search to retrieve documents that are most relevant to the question. Hybrid search is a good starting point, but it's still not enough because it doesn't offer the most precise, relevance between between the question and the documentation. It's more of a coarse-grained mechanism. So what we do at RunLLM is we apply another step. We apply an LLM-driven re-rank step, right, that ranks the retrieved documents based on their relevance via an LLM that's more reliable. And only docs that are determined as truly relevant by those LLMs are fed into the final generation step. Okay? So now let's talk about specialization, right? As I mentioned at the beginning, RunLLM targets highly technical products, right? So there's usually a mismatch between how their users talk about the product in common English versus the terminology used in the official documentation. And this can lead to degraded retrieval accuracy because of this mismatch. To solve this question, for each product, we apply parametric adaptation of LLMs via fine-tuning to train a mini expert, right? We first scan the data ingested and use an LLM to generate synthetic question-answer pairs. So the questions, represent these kind of real-world questions that the user may ask in layman term, and the answer is actually in the vocabulary of the official documentation. We then use this data set to fine-tune a small LLM, like Llama 3. And going back to Joey's analogy about this process, right? This is really like a new hire, a new grad, right? Onboarding in a new company. So typically it takes a new hire, a few months to get onboarded. But now we're talking about LLMs, right? So it only takes a matter of a couple hours. Then during this retrieval process, right? Instead of using the user question itself, we first have this fine-tuned LLM generates a hypothetical answer to the user's question and uses answer to perform retrieval. And we found that this query rewrite technology significantly improved RAG accuracy, which in turn improves our answer quality. And by the way, we also apply the concept of specialization to other steps in this pipeline as well. And so, for example, for easy tasks like tag filtering, we apply a smaller LLM to balance, we get satisfactory quality, we want to optimize for latency and cost. Well, for the most challenging task, right, this is final answer generation step, we want to apply the most powerful LLM possible, like the GPT 4.1 or Sonnet 3.7 to maximize answer quality. And now let's talk about composition. Right? Building the LLM inference pipeline with RAG and fine-tuning is really just the beginning. We actually had this pipeline at RunLLM from over a year ago, right? This is old stuff. And we found that that's actually not enough. Why? For three reasons. First, customers want tight control over the behavior of the agent, right? So for example, they shouldn't be allowed to talk about competitors, and shouldn't guess at an answer when it's uncertain, right? And also, maybe when a question comes in, instead of providing a direct answer, the LLM needs to provide, ask back a user certain clarification questions. Those type of control is what we're talking about. And the second reason is that oftentimes relying on ingested knowledge itself is not enough. And the LLM can benefit a lot from having access to other tools like web browsing, databases, code execution sandbox, and so on. And finally, we should give AI the ability to iterate on its answer dynamically instead of hard coding each step, right? Just like how humans solve problems, right? So for simple questions, it may just take a matter of a few website lookup, but for complicated questions, we actually want to iterate more, and have multiple iterations before we provide a better solution. So at RunLLM, we use an agentic decision-making pipeline, which is a dynamic composition of multiple operators. When a question comes in, we first use an LLM to classify whether this is something we should answer, right? If the question is malicious, not relevant, or need clarification, instead of providing an answer, we will directly get back to the user. And then the next step, right, is to use tools and reasonings to further augment our answer. The agent can talk to an MCP server, which has access to a handful of tools, including vector databases that stores our knowledge base. This is what we just talked about. And web browsing, of course. Monitoring tools like Datadog and stores customers' usage logs, or Grafana, right, that stores performance metrics. The MCP server can also use past memory, like MemGPT does for Joey's project, about this particular user's past conversation history as a context to further augment its answers. So based on the question, the agent will dynamically pick a subset of these APIs, generate queries against them, run those queries, get the results, combine with the question, and generates an initial version of the answer, right? And then we enter a self-critique process of judging whether this answer is good enough. We have a confidence threshold. If it's below a threshold, we actually go back to the reasoning step and keep iterating, right? Until either we get an answer that's good enough or a certain stopping condition is met. Maybe the customer has applied a stopping condition of, say, the total think time cannot exceed 2 minutes, right? Okay, so we've done everything Joey talked about. Careful use of data, specialization, composition. Why are we not a billion-dollar company yet, right? There must be something that's missing. Well, it turns out that there's a fourth aspect. And that's actually even more important. Joey doesn't see it since he's in this ivory tower, writing papers with his student. But we see it at RunLLM because we're talking to customers every day, right? So the secret is that we have to bring AI into the world. We cannot expect the world to come to AI. What it means is that we need to meet customers where they're at, right? Most of the companies we talk to already have a pre-established support workflow that runs on platforms like Slack, Discord, Zendesk, and Salesforce. So in reality, it's much more complicated. So if we just package all of these agentic pipelines as a ChatGPT-like bot, it's never going to generate business value. Take one of our customers as an example. Their users initiate support requests via Slack because users prefer Slack's lightweight way of communication. But for management and monitoring purpose, these conversations are actually turned into Zendesk ticket, and their support staff operates on the Zendesk side, and the responses and attachments are synchronized back to Slack. So how does RunLLM fit into this picture, right? So we have to embed our software into customers' existing flow as a deflection step. So how it works is that 100% of the questions from Slack will reach us first as an initial deflection. And say we're able to deflect or answer satisfactorily 50% of the questions. And only those remaining questions will reach Zendesk and tickets got created. And from that point onward, RunLLM becomes a co-pilot with our customer support staff to deliver better answer. And then those human-generated answers with RunLLM's augmentation are routed back to the Slack side. To achieve this, 2 lines of work need to happen. First, we need to, build integrations, right? It's data engineering, data infrastructure engineering. Building integrations against all existing popular platforms like Slack, Discord, Zendesk, Salesforce, Microsoft Teams, those type of stuff. And once that's done, we want to build a lightweight Python SDK that allows our customers to compose and construct their support workflow by exposing some of those key APIs and they use our SDK as building blocks to compose their business logic. As an example, I know most of the audience here are probably engineers, so I have to show some code. This is some SDK code snippet that defines the Slack Zendesk workflow. As we can see in the first picture, we first specify a listener, right, that listens for messages on the Slack channel. When a message is posted, we call our agent's answer API to run this agentic pipeline that we just talked about. And if the answer is something that we can generate and we have confidence score that's high enough, we respond directly. Otherwise, we make a call to this Slack Zendesk support handoff process to hand off to real humans. The nice part about this is that we just expose a set of APIs, and our customer just need to call out these APIs and focus on their business logic. Well, the complex internal implementations are left to us, right? We will handle those complexities for them. So we talked about, that slide. So we talked about specialization, but specialization is actually not something that we just do once. We actually want to do it multiple times, continuously. And it unlocks those cool features. Adaptive learning, right? So making mistake once is fine, but we don't want to make the same mistake twice. So we have a feedback loop mechanism. When we do something wrong, we get feedback, and those feedback got ingested in real time to our knowledge base. The second time a similar question is asked, we will never make the same mistake again. And then docs improvements, right? As we answer those questions, we run an async process that dynamically detects any documentation gaps or inconsistencies between documentations that we can find, and we surface that to our users. And those insights are everything that's unique to our customers' products. And as we gather tens of thousands of user questions, we use an LLM to batch process all the user questions and generate trends and insights, right? So what are the common topics that their users are asking? What are the common confusion points? We do sentiment analysis, those type of stuff. And finally, just another reminder that we work with highly technical product, right? So it always involves some kind of code. And we can take the user question and the code base and determine if this is something that's an error that user made, or is this something that's an error in the code base? And if so, we can actually make a GitHub pull request to fix the code, to fix the bug. Okay? Before I wrap up, I just want to spend a little bit of time talking about our customers, how they're using us, and some interesting observations. We released our product less than a year ago, and we've served so far over 300K developers worldwide, and more than 50 production deployments of RunLLM, as various forms, as chat widget on a website, Slack bot, Zendesk agent, and in-cloud deployment, and so on. We've answered over 250K questions. The number is doubling every few months. Our users love RunLLM. I'm not going to read out all of these quotes, but let me just dive into one case study of Arise. So Arise is an AI observability and evaluation company. They embedded RunLLM as a support agent within their cloud platform. So after deploying RunLLM, they observed 50% faster ticket resolution time, right? Which is great because it means their users are much more productive. And what's more interesting is that their users' 30-day retention has gone up by 15%. Which means RunLLM is actually doing a great job at building trust between our customer and their end users. The support workload is also reduced by 25%, meaning that those support staff now have more time to focus on more challenging support tickets that's not solvable by AI, maybe improving their product, or recycling some of their time, right, on improving their other skill sets. Another important finding is that AI support engineer has actually transformed the way technical support works, from both the end user perspective and from the company's perspective. For example, for our users, we noticed that they actually ask up to 10x more questions, becoming more open, confident and engaged. So it's actually interesting because if you build a feature that's kind of a piece of crap, your user will actually say that out loud to our AI assistant, and in the honest way possible, right? And the good thing about this is our agent will capture that via sentiment analysis, and will surface that as an insight to our customers, so they have a chance to fix it. And for support teams, right, teams actually shift their focus from this reactive way of ticket handling to a more proactive problem solving, right, freeing up resources for strategic customer relationships. And finally, for companies, companies transform support into more of a growth engine, right? So it's transitioning from a cost center to a business growth opportunity. It's gaining insights, building better products, and driving higher retention. So takeaways, AGI, right, is just the beginning. Foundation models unlock broad capabilities, but generalized intelligence alone isn't enough to solve business problems. Specialization is next, as Joey mentioned, right? Closing the gap between these foundation models and enterprise-grade solution requires deep specialization and fine-tuning of AI applications. And finally, RunLLM does a great job at specialization, right? So we deliberately tackled one of the most challenging problems in the industry, which is advanced AI tech support, and we proved that specialization drives real impact. That's all for the takeaway, and thanks for listening. We're happy to take questions.